Thursday nights now.
Aquaponics is a revolutionary method of agriculture that is organic, sustainable, highly efficient, allows for year-round cultivation, and can be lucrative when applied at a commercial level. The characteristics and potentials are key in the establishment of long-term subsistence practices. I hope that the following presentation produces enough information and inspiration for others to strongly consider using aquaculture as a means of subsistence. Aquaponics is a combination of aquaculture and hydroponics agriculture. Aquaculture is the farming of aquatic animals for the needs to fit the consumer market. Hydroponics is the cultivation of plants in nutrient-rich water as opposed to soil. The two systems work together in a symbiotic relationship to maintain overall homeostasis within the aquaponics system. The system itself is an interconnected arrangement of water flow and filtration stations. The flow begins in the rearing tanks where the fish are kept. Then through a network of filtration tanks where the fish byproducts are broken down and converted into fertilizer, and then the end destination before being recycled back into the rearing tanks are the lines leading straight to the hydroponic system itself. In the aquaponics system, water is recycled between aquaponics and the hydroponic system, and it can be mutually beneficial. Water from the aquaculture system is pumped into the hydroponic system. From here, the fish byproducts in the water, ones that would usually be toxic and kill off the fish, are then converted to nitrates, and then by nitrogen-fixing bacteria known as diazotrophs. The end product is a natural fertilizer for the plants. The backbone of the system is its ability to maintain output ratios, maintain levels of biodiversity and sustainability. These two output ratios are influenced by numerous chemical, physical variables, of which properly functioning aquaponic systems is able to self-regulate. In wild ecosystems, sustainability is directly affected by its level of biodiversity. Biodiversity to an ecosystem is the level of biological variation. Sustainability of an ecosystem is the ability to remain structurally sound and productive during periods of vulnerability and exploitation. An ecosystem's level of sustainability is directly connected to the level of biodiversity. A high level of biodiversity equates to a higher level of sustainability because it decreases the chance of the ecosystem totally failing due to disturbance or epidemic. When one biota is weakened or fails, other biota pick up the slack and begin to reorganize the process of the ecosystem. This is why it's important to have both the fish and the hydroponic system where the plants are kept. This is why it's beneficial for both of them, because it creates a closed circuit reciprocity between the two, and they're able to symbiotically benefit off of each other. So as I talked about, once the fish in the tank and the rearing tanks, their byproduct goes through a filtration system, and it goes through one tunnel into the first bank. And in here is where the nitrogen-fixing bacteria actually do their work and decompose the chemicals within the byproduct so that they're able to be converted back into nitrates. And as we all know, the majority of the atmosphere, the majority of the body, the majority of all living organic material is composed of nitrogen and carbon. So by doing this, it enables the system to have an elevated level of nitrogen retention throughout the entire period. What's interesting is that the polyculture design of this aquaponics system increases biodiversity within the system itself. And like I said, because it is a closed circuit, if the biodiversity were to drop and say that there was an epidemic or disease that swept through the crop, then the crop itself could be targeted and be completely wiped out because there's no more other genetic or organic biotics that the virus could attack. So having more variation within your ecosystem actually increases the chance of sustainability and their overall survival and higher yield rates of your crops. And again, this is because of the closed circuit system of the aquaponics. Using fish manure water is considered a source of organic fertilizer as it increases the nitrate levels without adding fertilizer. For commercial farmers and growers, this can be very important since certified organic produce oftentimes fetches a much higher market price than those that are not organically certified. So the benefits of such fertilization process also shrinks the overhead costs in the operation, and thus increasing profit margins. One of the hard things with hydroponic systems and being able to become completely certified organic is that unless you're making your own compost, and by that, by making your own compost, you have to then register your recipe and show all the chemical readouts and analysis showing that it is truly 100% organic. Now, with using the fish systems in the rearing tanks, you're able to give these fish a specific type of feed that you know for a fact is already proven and already has listed ingredients that are proven to be fully certified organic. And you can put this feed into the water, knowing that your fish are only producing byproducts that contain organic materials inside of them. And so that's one of the issues with why hydroponic systems or aquaponic systems are a bit more beneficial over hydroponics, because it's an easier way to get your stuff certified organic if you have the right materials and you have the right equipment necessary to get these samples taken. So another way that aquaculture creates a high profit margin is because of the high nitrogen retention in the system allows for plants to grow at a much more rapid pace than the hydroponic units do. In a hydroponic system, there may be times when fertilizer and other nutrients are absent at critical points of cultivation. Aquaponics takes away this possibility of human error, thus ensuring a higher yielding harvest. So basically, it's like you're growing a little kid, and it's just like having pure energy just transferred right into your body. So that way, in your most important periods of developmental growth, say you're a plant or in this case a child, you're basically getting straight like a main line of nutrients straight to your cells. So it's allowing them to grow at a very rapid rate. It's an analogy could be used compared to this could be used would be the use of the blood doping in the Olympics. They're not necessarily using a steroid, however, they are doping their blood by oxidizing the vasodilators within the bloodstream that allow for more oxygen to be taken in, and that gives them more energy. It's what Lance Armstrong was accused for. This could be analogous to that. So the nitrogen retention, the high nitrogen retention within the system is extremely beneficial for the overall sustainability of the aquaponics system itself. And like I said, it does produce high yields, much higher yields than systems that do not have such high nitrogen content. With a lower overhead and a higher efficiency rates, the hydroponic systems, and in combination with this sale of fish raised and the use of with a lower overhead and high efficiency rates than the hydroponic systems alone, and in combination with the sale of raised fish, the use of aquaculture creates a potential for huge profit margins. These profit margins can be seen in the family level of the family subsistence growing. It could be that they have these polychromatic or polyecotone, having two ecosystems put together like they do with the aquaculture, with the hydroponics. You're able to grow and harvest fish. You're able to grow and harvest vegetables. And so these two together create, right there and then and there, a balanced nutrition for a family that they could do in their own backyard. And they can do it for from anywhere from $1,000, or they can do it anywhere from $100,000. On a commercial level, like I said, the certified organic aspects, potentials of the aquaculture system allow for there to be a higher profit margin as well. When you have a higher or a lower cost yield ratio than your overhead projects, it increases your profit margin tenfold. So let's see, and this is also you're able to use under greenhouse conditions. You're able to cultivate all year long, because by doing this, you're taking away the physical variables of the outside and the climate, and being able to fully control them down to a T. So you can determine the heat in there, the humidity. You can determine how much water it's getting. So in conclusion, aquaponics is a quickly growing subsistence method that has been adopted by both individual and commercial levels. The organic nature of aquaponics systems ensures that the quality foods are being consumed. Using aquaponics as a subsistence method is also economically very wise because of the self-sustaining ability that ensures a higher efficiency rate that can be applied all year round, which in turn creates a lower cost yield ratio. The positive results of the cost-benefit analysis, along with the utility of year-round accessibility and quality foods, shows that aquaponics is a solid system and a user-friendly method of sustainability. I hope this presentation has given you some insight, at least on a basic level, to where you can even look into that, the use of aquaponics as a main source of biodiversity and sustainability and future permaculture. Thank you very much.